Okay, I think I'm gonna get started. Can everyone hear me well? Can you guys hear me at the back? Okay, go. Yeah, so welcome everyone to Intro to Frontend workshop. Before I start though, I just want to say that this is the first time I'm ever doing a workshop, so a little nervous about it. I might stutter, might say some sentences that doesn't end anywhere, so keep that in mind, but I'll try to be clear about what I'm about to share here today. And yeah, I hope you guys are not here to build your first front end for the project though, because you guys got what, less than 12 hours before the hackathon's over. So hopefully you're not here to learn how to start building a front end, but hopefully you are already starting a front end and want to learn some beginner concepts, or you haven't built a front end yet, but is interested in doing front end work, well, front end development in a future project. Or you don't know what front-end development is at all and kind of want an introduction to front-end, hence the name. With that, I will just do a quick introduction of myself. Oh, I didn't know there was an animation. My name is Ho Sim, but I go by Sim Ho because I'm from Korea and that's how names work there. I'm a senior in UCF doing computer science, and my professional background actually has nothing to do with front-end. I started some of my some of my professional or group experience started here at UCF on a research lab called Rare Labs. I was building a mobile application for biometric analysis. And then I moved on to doing Tech Rangers. I don't know if you guys ever heard of Tech Rangers before, but yeah, okay. It's a software engineering role at UCF where you are maintaining tools for Canvas. In here, we call it web courses. After that, I got an offer to do a summer internship at a bike component manufacturing company called SRAM. And I got the offer extended over a whole year until this summer. I did an internship at a small company that may have taken down the internet on Monday called AWS. That was a joke, by the way, it's not a small company. So they both had me do backend and DevOps and networking stuff, all of the things that I didn't have experience in. So that was surprising because all my resume was like web development, front-end applications, and then in the interview, that's all I would talk about. And they're like, okay, yeah, we'll let you do backend. Then I was like, okay, this is pretty new to me. And throughout the internships that I had, I learned a lot of things, but I want to share two things. One, that I can and like back-end development as well. I feel like I can call myself a full-stack developer now. And second, I still like front-end development. Even before joining UCF, I've done a lot of software engineering on my own, exploring a lot of different areas like game development, desktop applications, and then went to web and I was like, oh, this is really fun. And front-end especially is a lot of fun. And there are many reasons for that. First of all, is that the web itself is the most actively developing ecosystem out of all of software engineering. There's a funny website called Days Since Last JavaScript Framework. Basically, a new JavaScript framework for you to build your front-end application in. And if you go to that website right now, this was a screenshot like 30 minutes ago, it's a 0. There's a new JavaScript framework for you to work with today. So there's always something new that's coming up that makes it really exciting to learn new things and then build things in ways you haven't done before. And obviously everyone uses a website. Everyone goes to a browser and does something. And as time passes, people demand more. People just used to look at text content. Now you're looking at videos. Now you're playing whole games. Like I think Roblox used to run on the browser before they moved out of it. But yeah. Well, they still use browser technology, so pretty much you're having a game running on a browser. There are a lot of games that run on a browser. So yeah, a lot of activity going on and a lot of development going on there, and I find that really exciting. Why front end though is because, well, there's a lot of activity going on, as I said, but I really like when I build something and it immediately shows up. When I build back end, I know that I built something, but then it's hard to really see that I have done something that's impactful. And that's same for the users as well. When an app is built, the user usually looks at what was built in front of them, what they can see, more than what is it happening in the background. Sure, if you are making like a 30% improvement, 50% improvement to certain requests that happen in the background, then the users are definitely going to feel it. But the front-end developer is the one who's responsible for how that is communicated to the user. And I find that a lot of fun, very satisfying. And then there are a lot of challenges that comes with it as well that I'm going to talk about today on a beginner level. But I want to first talk about a common misconception. Whenever I talk with people who haven't done front-end development before or just getting into software engineering, I ask them, why haven't you tried front-end development before yet? And they tell me, well, I'm not interested because I'm not really good at design. And the thing is, designing the front end is different from implementing the front end. Front developers implement the elements that the users see, but the actual work of designing it and researching what the user would like to look at and how they would experience the whole application is a job for UI UX researcher. When you're building a project at the hackathon, yeah, you are going to design and implement at the same time. If you're in a smaller company, at a startup, you're going to have to fit into a lot of shoes at the same time. But in most well-defined organizations, they will have a separate UI UX researcher or engineer or designer or whatever term they use nowadays, and a separate front-end developer. And that is what I'm going to talk about, the front-end developer's role. There are a lot of platforms to build front-end. I'm sure not everyone here is here to build for the web. Of course, there's mobile, which separates to Android or iOS. And there is mixed reality as well, virtual reality platforms that you can build in. The concepts I'm about to talk about here today are common across all of them. And here are the six that I was managed to, here are the six that I was able to fit into an hour session. I was told that this was an hour session. Hopefully it is. Someone said 30 minutes. I hope it's not. If it is 30 minutes, I won't be able to go through all of them, but you get the idea. It starts with rendering and presentation, then componentization, event handling, state management, responsive design, and API communication, which I will all demo using HTML, CSS, and JavaScript, since that's what I am really specialized in. But again, the concept works across all of the field. It's just that the exact implementation that I'm going to demo here is going to be in those technologies. And if you haven't built a web front-end before, and you want to get into it, I highly recommend starting with the web first, because it gives you, well, everyone uses the web again, so you get to learn something pretty useful. And second, the technology that you learn through web development can be used in mobile development and desktop application development as well. So you may have heard of React as the most popular technology that you use to build front end. You can use that to build desktop application by putting it on top of another technology called Electron. And for mobile apps, you can build cross-platform stuff with React Native / Expo. With that, I'm going to start with rendering and presentation. And if you have any questions, feel free to pause, stop me, and then I will try to explain if I have the time. Or if I don't, I'll let you know that I'll have to answer that at the end of it. Okay. My slides aren't great, but the demo will be okay. The goal is, how do I get things onto the screen? The designer has given you the elements to show. Now you have to know how to show it on the platform that you're working with. For the web, you are trying to understand how the browser works with things. On Android, you're trying to understand how the operating system allows you to show things. If you're building desktop applications, you also have to understand how Windows, Linux, and Mac OS or any other special OSs that you guys are using allows you to display things onto the screen. There are a lot of abstraction layers and technologies that make it really easy to just understand, but as for the browser, we have three tools in our hand to start with, which is with HTML, which is the structure, content, and then CSS, the styling, and then JavaScript, which wrangles all of them together, allows you to interact and manipulate all the data that is on it. To give an example, throughout the whole workshop, I'm actually going to build a simple to-do app with the HTML, CSS, and JavaScript. So the first thing I'm going to show here is I'm going to Alt-Tab and go over to the code that I have, which doesn't show up because I didn't type HTML in it. And that's not how you type it. HTML. Okay. Let me do this. Is that easier to see? Should be. So what you see here is the skeleton, the structure of the content. And I'm not going to go over like what is a button and what is an input and so on, but what you should know is that depending on the platform that you're building on, they will provide you these abstractions of the components that the user is going to communicate with, interact with, and some of them might not. Especially in game development, when you're building a UI, you may not have the level of abstraction for interfaces that browser just provides out of the box. So for example, button, you might have to create what a button is to get to the button, not just have this really simple button element. And how this looks like on the web, I need to get out of this and then show you right here. This is how it looks like. It doesn't look like a to-do app at all. It's really bare bones. So this is where you use CSS to style things to make things look good. The browser wants you to define the place that the CSS file is going to be fetched from. What I mean by that is that the browser only really asks for the HTML file, and on top of the HTML file, you have to, oh, my AI just told me what to do. The browser is going to ask for, where's the styles? So in the HTML, you just describe, well, it's in to do. And I hope that didn't work. So what we're going to do instead is going to go over to the thing that I already built out because I wasn't going to sit here and code it all up. We can see up here, there is head with link style sheets. And then there's the CSS files. If I go over to to-do CSS, you can see a bunch of different like description on how the styles are supposed to look like. And if I switch over to the page that I created for this demo, it now looks more like a to-do app. We have the task title here. We have planned, in progress, complete as like the status for it, and then low, medium, high, kind of the priorities for it. Doesn't really have the best indicator as to what they are, but that's what we have right now. So we have HTML and CSS. We know how to style things and we know how to present things. But this is a useless to-do app. Even though I create a new task, and press add task, oh, I accidentally forgot to not include it. Well, add task isn't supposed to work for the demo because I haven't added JavaScript yet. Let's just say that you didn't see what just happened. So add task does nothing because all we have is HTML and CSS. I said that JavaScript can manipulate and interact with existing HTML. So it can create and delete HTML. So instead of just defining what we're going to see on HTML, we can tell JavaScript to create the HTML that we're going to see. And while I'm not going to cover it in this workshop, you will learn that React, the whole idea is that we have no HTML at all, and you just send in JavaScript to tell it to build the entire application. And I'm just showing a glimpse of that. So at the bottom here, I have script called to-do rendering. It's just a name that I came up with for the demo. The name doesn't really matter. I'm putting it way at the bottom, and that is important. I'm putting it way at the bottom, and the code has several things that happen. I'm just going to go over this function really briefly. When you're building for the web, there is a thing called the DOM, Document Object Model, and basically, and JavaScript has these tools that allow you to manipulate the DOM as well. So you have a create element div, and then there is, the next slide says to-do item dot class name to-do item. It's assigning the string to-do item for the class name, which is doing the exact same thing down here. We have a div with a class that has to-do item. So we're basically recreating the thing that we just saw in HTML with just JavaScript. It's a lot of words. We have status. It's an array of strings. And then for each of them, we are creating an option element. And then we have the status inside and so on. And we're doing the same for priority. We're creating an array for each creating option elements for them, putting the text content in them, and then appending to the child, meaning that if I press F12 here, it's probably really hard to see because, maybe not. But if you look at it right here, the to-do list, we have select element that have options. That is how there are options in here. I'm getting too deep into HTML. Basically, this is how the task item is created. You may notice some, if you have already done some HTML, CSS, JavaScript, you may notice some issues with the way I wrote this, and it's deliberate. But let's move on to the next topic. Yeah, so that's how you render and present things on the web, and general idea of how you would do it on other platforms. Next one is componentization. This is a concept that isn't just for front-end development. This is just general in software engineering. Whenever you have a repetitive pattern that you recognize, you want to abstract it into some kind of variable or a function or any tool that you're given in your programming language so that you can just reuse that abstraction instead of repeatedly writing it. Was there any aspect that you guys noticed in our application, I'm going to have to use it again, here, that is repetitive or is similar to another? Yes. Yeah, so that's why we have a function for create task item, so that we just have to call that function to create the tasks, right? Is that what you meant? Yeah. The other part that I deliberately didn't make a function for are status. You can see here, status option, we have an array, and then we go through a for loop for the array, and then we append it to the select element. Same for priority. We have an array, and then we go to a for loop and append it to the select element. We're doing the same thing over and over again, and that is not only against just software engineering principles, but not something you want to do for front-end development as well. Because what if you want to change the functionality of it? Maybe they're now represented in different colors. We don't want to be updating it in 2 positions, or maybe they're adding new functionality. Maybe every time I click on the select, it just like bursts into bubbles or something like that. So the better approach is componentization, and I have a result here. What we will be doing instead is create a function called create select. And here, you don't care about what options there are, you just take it as an argument, and then you for loop through it, and then return the select. If we go back down to create to-do item now, instead of having to do the for loop multiple times, I can just do status select equal create select, and then just pass in the arguments there. Yeah, and that's how you want to do for every component that you're building. The example that I can't really show right here because it's going to be really complex is single responsibility. Whenever you are building for building any component, in this case we're building a to-do app, you want the component to just be representing one thing. I said that, but I don't really have a good example to really tell you what that means. So hopefully I get to a point later in the workshop that I can give a better example. But yeah, that's what componentization is, abstracting it into a way that is repeatable. Okay, back to the next concept. I feel like I should just stay on this page because I'm going to keep going to the demo. State management. Now, this is the most complex part that comes to front-end development. I'm just going to go over the most basic one because I can accidentally go into too much detail. State is the values that change and determine how elements are displayed on the screen. So we have the website, the task here. This task has different states. It can either be in planned status, in progress, or complete. And then it can also have a different priority for it. Let's add a new feature for this to-do app. What we want to do is we want to figure out how to, we want to display all the tasks that, no, we want to display the number of tasks that are currently in progress and number of tasks that are done and so on. And same for the priorities as well. How will we do that? Our current approach has been just injecting the HTML. Let me show the code again. We are just appending child, and then basically we're adding HTML to HTML. So the only way we know the current list of all the status of, the status of all the tasks that we have is by walking through the HTML individually. We'd have to go to the body tag and then go to the task and then walk through and find the string that says planned or in ongoing or complete, and you have to gather all of that and then put it up somewhere on the screen. To give a better representation, I'm going to just go to state. And this is what we're trying to do. We're going to have a status breakdown. But in order to get this information from a bunch of tasks, we don't really have a good way to actually pull this information out. Right now I already have the JavaScript in, so it already says 3. But how is it doing that? Well, the way we're doing it is by having a central state. We're having one location where all this information about what tasks exist and what information they have inside of it, and using that as the source of truth. To show you what I mean by that, I have 2 versions. I'm going to first start with the imperative. This is the state that we're trying to keep track of, the to-dos. It's an array because we're going to display it as an array as we see here, right? Or at least we're going to store it in an array so that we can for loop through it and display it on a list. Then we have this create to-do element, which is the same thing as create to-do as we saw somewhere here. Create to-do item. It's renamed as create to-do element now. It's doing the same thing. It's doing, it's creating an element called div and then adding a class name. The special thing it's doing now is that it's adding a to-do ID. That is how we're going to keep track of the unique tasks that still exist. And we're going to keep going from there. We add all the tasks and we have these functions. Whenever we create the element, the select element and then the priority element, we're also going to update the to-do status. The function here, ignore the errors there. It just goes through the to-do and first finds if the to-do exists. Now, I told you that before this to-do or to-dos array, we would have to walk through each HTML and find the to-dos. But now that we already have a to-dos array that gives us the source of all the information, we can just do any operations here. Here we're using the find operation to find the exact ID. And then with that, we're using the status that it already had to update the status counter. So if the old status was planned and it changed ongoing, we found the exact to-do by the ID and then update the status and the counter as well. So update counter, boom. This one went down by 1 and in progress went up by 1. And that was possible because we are tracking the state in a central variable. So that is the imperative way to do it. And you may or may not have heard of imperative and declarative way of programming. The simplest way to explain that is by the way that we're doing it right now. So every time you update the to-do status, you're updating the status counter as well. Remember when I said single responsibility? The update to-do status shouldn't really care about updating the status counter. It should simply just update the to-do status. But it's doing multiple things at the same time. This is not the single responsibility that we're looking for in software. And let's say I am trying to add even more features. When a task gets updated, maybe something else is going to happen as well. Maybe I want to change how the status is actually being updated, which will change the logic in here, affecting all the ways that the status counter is being updated. Now you're making all these dependencies with each other that you do not want to deal with and make things more complex. But that's how you have to do it in imperative programming method. where you are, every time an event happens, then you have to update the other things that needs to be updated based on that event. That was probably a very complex way to put it. Let's make it easier, the declarative way. What if, when we update the state, this simply just updates the state, but somehow the status breakdown and the priority breakdown is listening to the state being updated, and once it does, it just changes it. In fact, let's not even care about the state. Whenever something changes in the state, what if we just refresh the entire screen? So so status breakdown doesn't have to know what value it has to add or delete. It just refreshes itself, and the value happens to be updated already. That is the declarative way to do it, and I'll show it better with this version of code here. The difference is not that big. The only thing that's different is that we have this new function called render. In the render function, we have the to-do list and we completely empty it. We're putting it as an empty string. And then we have the to-dos array that we created before, right? We're going to for loop through it and then just create the elements again. Status, priority, they're going to all reset to 0. And once it resets to 0, it's going to just go through the to-dos array and then going to add the relevant status counts and the priority counts as well. And then once that's done, it's just going to update the text content for all the data that is actually going in here. So whenever I add a new to-do, it's going to, by default, create a medium priority status plan. And now we want to update the count to, well, add one more count to the status, right? Now there's an additional planned to-do. We're just going to add it to this to-dos state that we have, and we're going to just run a function called render. We're going to agree that every function that we have needs to run the function render. So even though, yes, add to-do is doing render and adding a to-do at the same time, so now you have two responsibilities, which is what I said we shouldn't do. But if we all agree that any function that changes states will also have to run render, then it just becomes its own responsibility. Technically, it is a single responsibility still. So if I push the to-do, it will run render, and then the render will just recalculate all the things that it needs to show and show it again. In fact, the version that I was showing you was the declarative version. So if I add a new thing, the whole page refreshes. You can't see it because it's so fast, but the whole page is refreshing and then loading this new thing. This is how React does things, actually. React has a concept of this is the most simple version of React that you can create in JavaScript. Instead of having to create this render function on your own, React as a framework will tell you how to re-render the whole thing, will automatically re-render the whole thing when a state changes. That is why I have the definitions as imperative is event-based. Each event needs to know what other things need to be updated. Declarative is when a state updates, everything that depends on it will update as well. And I added polling here because it is there's a concept in game development a lot of times where you're frequently just checking whether the state has a data that's different. So you're constantly checking, have you changed? Have you changed? And it will keep saying no until something has changed. And you're like, okay, that's changed. I mean, I know there are libraries that in game development as well that makes that event-based as well, which is a much smarter way to check whether something is updated. But most game engines just start off of polling. So that I decided to mention that as well. Okay. Next one is responsive design. You must understand that the application that you're building is not going to be on the same device all the time. If I'm building a website, my laptop screen is actually 16 by 10. 16 by 9 is the most common aspect ratio, but that's different. You can be on the phone, which is 9 by 16 a lot of times, but it could be slightly different based on the device you're working on. If you're building a game, somebody may be looking at the looking at it on a TV that's like 21 by 9 or 4 by 3 because they're still on a CRT. So the designer is going to give you all these different designs for how they're supposed to look in these different devices. It's your job to figure out how to implement that in the environment that you're trying to implement. For the web, we have CSS that provides styles, and we have a thing called media query. I'm going to just go over to responsive, CSS. And you can see here, there's a media tag, and it says max width is 480 pixels. So any HTML that is written down here any CSS that is written down here is in effect until the width of the screen is 480 pixels. After that, all these gets candled. So it's kind of like an if condition. If the screen size is between 0 to 480 pixels, then it will be using this CSS. Otherwise, don't use it, kind of thing. When it comes to game development, the only platform that I know is Unity, and Unity does have a CSS-like way to implement styles, so you can do media queries there as well. I know Android does the same with XML instead of CSS. So there are various ways to do it depending on the platform, but ultimately it's something you have to consider while you're building it. I can show you the version of the website before and after, actually. So if I press F12 here, I can make it into different aspect ratios. If I go over to mobile, oh, it looks like shit. I can't see anything. The more responsive version would be, let's refresh, the responsive version would look like this. And then it will automatically update the size given the task we have, given the screen we have. So that's responsive design. Now, finally, I have API communication. Not every front-end application needs to communicate with a backend or with any APIs, but most front-end will be communicating with one. What I mean by that is just a way that the front-end will communicate with the back-end. The back-end itself could be, the browser itself could be the back-end in some cases, or you could have a server running somewhere else, or it could be someone else's server, like AWS, or what's a common one? Maybe you want to talk to GitHub and get some information out of that. They have their servers, and you can communicate with them through an API endpoint. There are different types of APIs, and I hope you guys already went to an intro to API and intro to backend before coming here, because I'm not going to go too deep into this. But there is REST API, but there are other ones like GraphQL, gRPC, tRPC, and others. The only one that we're going to care about today is REST API, though. One thing to note in any kind of communication with a backend, which I forgot to mention, when it comes to games, your backend could be the operating system itself, or any desktop application or mobile application. You might have to communicate with the file system, try to pull in images that you have to render on the screen and so on, or maybe the journals that you wrote on a mobile application. That can be itself, that is also part of API communication. And what you have to know is that these communication has to be asynchronous. And asynchronous communication just means that the front end must explicitly wait for the response without freezing. Or more so that you expect it to take longer than you want it to, and you have to handle it by not freezing. So, an example. Let's say I have the to-do list, and to fetch the to-do list from the backend, it takes like 15 seconds because someone who built the backend is a terrible backend developer. You don't want the user's interactions to be frozen after that. You don't want the line of code to just be like, okay, I'm waiting for the response, and just not run the rest of the code. So the way we handle it is by asynchronous, and this depends really heavily on the programming language that you're using. In JavaScript, we have promises. So let's go over to the There's an API version. I already built a backend for this demo, so we don't have to build it here. But the thing that I want to show you is down here. So we got a delete function. And the way that you fetch, basically make a call to the backend or any HTTPS request is through a function called fetch. And we are awaiting the response from it. If I just remove the await part and look at response, it says the response is, does it show up? Oh yeah, it says response promise response, right? So this is a promise to give a response. What's happening here is that when this line of code runs, well, if I don't have await, when this line of code runs, it makes the request. And it's like, okay, I'll give you, I promise you to give you a response, but I'm not giving you it yet. Which allows you to just continue running the thing below here. So let's say I don't care for getting the response immediately, and I do something here. And then I actually want the response now, so I'm gonna do actual response. There. Actual response, await response. Await is the syntax that you use in JavaScript to say, okay, I know that you're doing something asynchronous, something in the background. Now I actually want the data. So I will wait for it at this line of code. This is where you can actually get the response from it. If it is complete, then it will be immediate. If it's not, you will still be waiting for the 15 seconds that you had to wait for and work with it. In this case, we are doing await immediately after because we don't care about doing any operations beforehand, and we want the response immediately. So we're like, okay, it takes 15 seconds. I'll just await it right at the line of code that I'm calling it on. And yeah, that's pretty much it for API communication without going into an intro to API course. Not only do you want to do asynchronous communication create asynchronous functions just in API communication, but you want to do that for any function that is highly compute intensive. Let's say, even just on the front end, you have some calculation that that takes a really long time, and you don't want the browser to freeze in that instance, and you don't really need the response immediately. Make an asynchronous function for it, and have it run in the background, and when you actually need the data, then call await and actually resolve it. Await is one out of many ways to do it, but that's the example I'm showing here. So there you go. I should probably show you the complete version. Index API. Oh. I think what I tried to do was, actually, turns out I did an update during my practice for the demo, for the workshop, and now this task is persistent. So if I refresh the screen, it's stored in the back end because whenever I make a request, it gets saved. So there you go. If I delete, it won't show up. Yeah, that's actually all for the demo and all the concepts that I wanted to cover in general. I'm sure some of you guys may have wanted like an actual deep dive into how web development works and what front development works, but I want to keep it general enough so it may have been a little like too vague as to how you're supposed to do things, but without having additional 2 hours to do this demo, this is the best I could have done for that. And I didn't even cover all of it. There are a lot of other things that you have to consider when it comes to front-end development. There's caching, which sometimes you want to make a request. No, you don't want to make a request to the backend, but your user is asking to. So you're like, okay, well, I already know what that information is going to be. Let me just store it on the front end and then show that information then. Or maybe the back end says, hey, I have an information that I'm going to send it to you because you asked for it, but I know that this information is going to be the same in 3 days. Then for the next 3 days. Then you want to be like, okay, I'll store it in the front end, and whenever the user requests it, I'm going to smartly recognize that it has to be, I'm going to just show what I already have instead of actually making the request to the back end again. So there's some optimization that you're making there. Speaking of optimization, there's also optimistic updates. You may have noticed in some applications when you make a change, maybe you're working on a to-do list and you change the status to planned, and it immediately updates. But how could it have made that update so fast when the backend is somewhere else? At least there needs to be some amount of delay, but somehow the app knows that it has to display the status differently for that task. That is where optimistic update comes in, where the front end is responsible for guessing optimistically that this is going to be the end result of the backend response and putting that on the screen first before the response actually comes to the user. Once the backend says, actually, the optimistic guess that you made is wrong, you need to display this instead, then you're gonna revert it, or if it's the same, then you get to keep it. And then there are tons of other things too. Accessibility, you gotta make sure that disabled people are able to interact with your application easily. Automated testing, somehow that's our job. Complex state management, we had just to-dos as a state, but once you have a much bigger application, you're gonna use something like React, and you're gonna want to do global state management, manage states for different network requests, and how are you gonna group them together, and how are you gonna pass it over to different components. That gets really complicated, which is why I say state management is the hardest part. But we don't have enough time to go over all of them. So hopefully the foundation that I've given so far is reasonable. That is all I have to talk about. If anyone has questions on the things that I talked about, feel free to ask them now. Otherwise, thank you for listening.
Is it drawing competition where you will draw monsters and stuff, or like even right across from here?
Hey.
What about the points to the winner?
I have a question. So once you write the code, what do you like deploy? Like, when you like run the code?
So for front-end web applications, right?
Yeah.
It depends on where you. There are a lot of places you can deploy. I like to deploy it on VIII because they just have a very generous fee to it. And the way that they allow you to deploy it is you just link it to a GitHub repository. And what are you asking about the technical like decision I made between different platforms? Or?
Yeah. No, this one. And also, I have another question. So if someone wants to go into full stack, so should he start from front end and then go to back end, or like back end and then front end?
I don't think it matters. I think you can do either of them.
Yeah.
I started from front end because it's just easy. I think it's easier to do so because if you start from the back end, you need some way to actually see the result that you built.
That makes sense.
Yeah.
Thanks so much.
No problem.